Hey, good. Sorry, you're getting me shaking my head at the beginning of every one of these videos, but I use Streamlabs to record and it is just crashing like crazy on me lately. Anyway, enough about my problems. Let's talk about your problems. So this is going to be a relatively, hopefully short demo where we do a little bit of HTTPS. You're going to set up a self-signed certificate, meaning that traffic should be private, talking to your server. Now, there is one thing to kind of talk about here, and that is that self-signed certificates, not necessarily the greatest thing in the world, because I am certifying that my server is good, and you just have to trust me. Let's back up a touch, though. What we're going to be covering really today is the concept of HTTPS. In a very high level, I have some readings for you to dig into it, but basically the idea is that traffic is encrypted between you and the server. And the idea is that people that are trying to eavesdrop on your connections. So let's say if I want to go to Amazon or I want to go buy something online or I want to send some sensitive information. If I'm using normal HTTP, that traffic can be unpackaged and read by anybody with the technology to do that. Once we add on HTTPS, that traffic's encrypted and it becomes a lot more difficult to figure out what's happening. Obviously, with enough time and effort, you can break into that. Nothing is foolproof in the security realm, but the idea is that it is a massive step forward towards securing our traffic. Now, HTTPS, this started out as SSL. You've probably heard of SSL. I'm going to keep talking about it like SSL. That's the common name. It's really TLS now. The acronym changed because the protocol changed. Everybody still refers to it as SSL. All it really is a protocol for encrypting traffic between client and server, and it's based around the concept of a certificate that is signed by some authority that basically dictates how the encryption works, without going deep into public and private keys and all that fun stuff. Um, Now, the thing that I've got here that you can see, this Let's Encrypt site, this is one of the common, certificate signers that are out there. There are other ones as well. And even with Apache, you can install something like certbots, which is one program which will help you set up HTTPS on your server. The one thing is that you need a domain name for it. So I would need to register efredericks.net, for instance, or gvsu.edu for any of this to work. Okay, and again, I don't want you to pay for anything in this class. Don't rush out and buy a domain name. You can if you want. Again, I'm not going to stop you, but you shouldn't need to. One thing that we can do is we can sign the certificate ourselves, meaning that because we have a web server, and sorry, a server in general, we have the technology and the programs available to sign our own certificates. And what you're going to see when we do that is that every browser is going to yell, yell, yell at you for browsing the site because the server itself is the one signing the certificate. That would be like me saying, hey, I have all this um, great fake things to purchase for retail value. Come buy my real things. I promise you that it's real. And then you come here and you buy it and it's all stolen property. Or, I have the ability to snoop on your traffic because I'm a, bad person and I'm just snooping, right? The idea is that this is not a great practice. If you are setting up a real web application on a real server with real money involved, buy a domain name, set up an actual certificate with a trusted authority. This is just a demo to show you how it can work. Enough caveats. All right, I've got a link here for you for how to set up a nice self-signed SSL certificate. Again, if you are doing this in the public web, don't do this. You can actually do this kind of thing internally. You could set up your own SSL certificate authority on, say, a local network if you have an intranet application or something, inside. Again, don't do this in reality, but it's a nice walkthrough of how to actually do things. Okay, so this site is going to be for the servers that we set up. The state of my virtual machine here is basically I set up the virtual hosts recently, so I still have that kind of lying around my system. So we'll see how it goes. All right, first things first, let's update and upgrade everything. Sudo apt update ampersand sudo apt upgrade, just to make sure everything's up to date. It's usually a good habit to get into anyway, because it will keep everything, up to date on your machine. All right, everything's good. Oh, sure, we have some updates. Read over what they're updating usually. I didn't notice anything out of line there. And once that's done, we have Apache already, so we can skip this step. This step we are not going to skip. So before, when you set up your servers, you allowed the port 80, standard HTTP non-encrypted traffic port. So that's port 80. Port 443 is going to be the HTTPS port. And you allowed 8080 last time as well. That was our development server, right? Or our hacked default server in a way. So what we have to do now is allow 443. We can do this in multiple ways again. This line here is going to open up everything traffic related in Apache. We could also just say sudo ufw allow 443. That works, so we see the rule added. I'm going to drop this in here just to show you that, okay, it added something else too. Fair enough. 443 is the one we care about. Anyway, firewall port is open. This should already be open in Google Cloud as well. If you remember last time as well, we had that firewall issue. So if I go to the firewall here, and we go to default allow HTTPS, we see this is allowed. We see 443 is coming in on the TCP protocol. So it is allowed through Google. It is now allowed through our server. We can handle traffic on 443, right? All right, and shift you back over here. Hey, look, it's my Spotify. Something you don't need to see, or don't care to see. What is going on here? Okay. There we go. Sorry. So, Apache's allowed. First things first, we need the mod SSL package enabled. So this is a module for Apache that's going to let us handle TLS connections. So sudo a2 enmod SSL. I enabled it before to make sure this demo worked. You will see now enabled basically. Let's restart Apache. Restart Apache 2. Reload Apache. Reload the config file. Everything's good. SSL now exists on our system. If you remember to the HTTP lecture, I've got those little, I had that figure with like all the little blocks, mod underscore, mod underscore, mod underscore, plugged into Apache. That's basically what mod SSL is here. It is a plugin. All right, now let's create the certificate. We are going to, again, host a self-signed certificate. We're going to use OpenSSL, which is a program that is going to generate basically public and private keys for us. Now, it has some modifiers on here that I would highly encourage you read through to understand what they do. For instance, the way this one's being created is that we're generating the X509 certificate, which is the infrastructure we care about. Here's how long it's alive for. Here's our key. Here's how many bits it's going to comprise. Again, these are all things which you can modify. We're just going to use the defaults for now. What this is going to do is it's going to generate a key, and it's going to generate a certificate. All right, so let's go ahead and run this. All right, so we start generating a key. We get a key file. If you've ever set up an SSH key, this should look relatively familiar. All right, now we're going to create our distinguished name. So let's let our country code be placed here. Say Michigan, locality, sure, let's add Allendale, just give some more information, GVSU. I'm just going to leave the rest of it blank. These are all things which are going to populate the certificate. If somebody wanted to check out who is actually signing this thing. So I probably should have put my name and email address so that I'm associated with it. But for the purposes of this demo, not super necessary. Okay, so we have a certificate, we have a key. Let's tell Apache to actually use this. All right, what we're going to do now is edit our example site. etc Apache 2 sites available example.conf. All right, this should look familiar if you went through the virtual host demo. Okay. What I'm going to do now is I'm actually going to leave these here, except I'm going to copy my first one, change the port to 443, leave all this the same, except I'm going to add on this information here. Okay, so let's leave the logs and let's copy and paste this SSL information. And let's fix the formatting a touch. So if it's coming in on 443, it is going to use SSL. Here's where the certificate file is. Here is where our key is. All right. Everything else should be the same if you can easily copy and paste this. In Nano, I don't remember the copy paste commands. In Vim, it's very easy. YY and then P will copy and paste a line. Shift V, scroll up, Y, P. Again, I love Vim, not everybody does. Anyway, so we have 443 here. Let's go ahead and read ahead. We already have our example site, so we can skip this step, skip this step. We know that this site exists, right? Because we already created example before. If you want to route this to a different subdomain, you are welcome to create, a new server, create a new folder, new site, all of the stuff that we did before. Nothing wrong with pointing your SSL, or sorry, your TLS based connection to a different site. And I keep calling it SSL just out of habit. It's actually TLS. All right. So life should be good here. Now, our site is already enabled, right? We can try this just to check. Example. Again, already enabled. Clear this. Sudo apache 2 control config test. Syntax okay. We didn't screw anything up in our typing. Let's reload Apache. Reload Apache 2. In theory, this should work. So refresh this. Still works. Port 8080. Still works. Moment of truth. Let's add on an S. What we should see is our same site as before, except it's now encrypted. Hey, we got it. What do we see here? This is an error that you've probably seen many times browsing on the web. Maybe you didn't know what it was. Somebody is self-hosting a certificate. This could be a bad thing, right? Chrome recognizes this, and Firefox and most common browsers will recognize this to be a security threat. Self-signed certificates are not really a good thing. It should be from a trusted authority, and me, with a random Google Cloud instance that spun up X hours ago, is not trusted on the internet. Okay, now we know this is fine because we just set it up. We can click advanced, proceed. Hey, here's our page again, but we see HTTPS. This traffic is encrypted based on the certificate and the key that we created. All right, but again, Google and every browser is going to warn you this is not a trusted site. Be very careful what you put in here. All right, and now we could also do something here too, where let's redirect our default host. So maybe we do not want to allow unencrypted traffic. This is kind of a nice thing to do on the internet these days. I browse to HTTP, mywebsite.com. It should be encrypted. Send them to HTTPS. We can do this with Apache and its directives. So let's actually go ahead and do this right now. And one thing I'm going to need is the IP address here, because it needs to know exactly where to send me. All right, so let's go ahead and edit our example.conf file again. So again, Apache 2, sites available, example.conf. And in this virtual host 80, I'm going to redirect it to the secured version. All right, so I'm going to say, oops, redirect / HTTPS / copy and paste the wrong thing. We want this IP. There we go. And there we go. So if I browse to my site on port 80, which again is the default, redirect to the secure version of this. All right. Now, save and close. Do our config test. Syntax okay. Reload Apache. Good, good. HTTPS still works. However, when I take off the S, we go to the general unencrypted version. We get redirected. I didn't hit enter. So there we go, automatically redirected. We have a self-signed certificate. Again, don't trust it if you see that. Be very careful if you're going to somebody else's site and it's self-hosted. But it's a very easy thing to do. Now, let's say you have a domain name. Okay, what would that process look like? Well, instead of self-signing it, you would install a program. Again, it's called, one of the nice ones is certbot. And I can actually put this link here as well. Basically, what this reaches out to is the Let's Encrypt server, and it's going to link up your web server with this external trusted authority. Then you get that certificate, but it relies on domain names, and that is not something that you should pay for this class. Anyway, probably enough of a demo for you all here. Hope you all had a good time. I will see you in the next video. Bye, everybody.